All right, here's part 2. So we're going to be using properties 3 and 4. Those properties are in the book, but maybe you took notes on them as well to solve these problems here. And I have steps written at the side. So really our steps to solve exponential equations, they're the same for log 2, but they're just the reverse, is first isolate just the exponential term. So for step 1, if I want to isolate just the exponential term, I'm going to move everything away from it. So I'm going to add 29 to both sides. And when I do that, I'm left with 10 to the x equals 80. Yes, I'm not very fast at my addition. All right, that's step 1. So see how my exponential term is isolated? Step 2 says to rewrite as a log equation. I'm going to say that we're taking the log of both sides to get x by itself. So I undo an exponent by taking the log of it at the same base. So what I have here, this is step 2, is I have log of 10 to the x equals log of 80. This base 10 here kind of cancels that out, giving me x equals log of 80. And honestly, if you wanted to leave that as your answer, that's the more exact answer. It shows me that you understand versus just putting it in your calculator. So we can just leave it there. But then step 3 does say if they want the approximate answer, use the calculator to find the value. So if we take our calculator and we want to do log of 80 and we hit enter, we see it's about 1.9. So my answer here is approximately 1.9. All right. So what do you guys think is my first step in getting just the exponential part, the e to the x, by itself? Take a moment and think about that. All right, so your first step is going to be you want to add 5 to both sides. Remember, we undo equations by doing the reverse of PEMDAS, which would leave us 3e to the x plus 1 equals 12. I still need to get rid of that 3, so I'm going to undo multiplication with division, leaving me with e to the x plus 1 equals 4. This is step 1. Step 2 says to take the log of both sides. So when I do that, I'm going to take the natural log of e to the x plus 1 equals natural log of 4. When I do that, these cancel each other out, and I get just x plus 1 equals natural log of 4. And now if I solve for x, I want to have x, I'm going to subtract 1 from both sides, giving me x equals the natural log of 4 minus 1. That you could stick in your calculator, but this answer is fine as well, as this is the most accurate. But just to show you for the lesson, we'll take the natural log of 4, and then we'll subtract 1, and that gives us 0.386. So this is equal to approximately 0.386. All right. So pause if you need to finish copying these down. I'll put this here so you can freeze the screen. I'm going to move on to doing the opposite. The steps are really similar. So when starting with the log, instead of isolating the exponential term, we're going to isolate the log term. So on this case, step 1 is going to be me subtracting 1 from both sides, giving me 2 log of 7x equals 3. And now I want to divide both sides by 2 first because I need to get the log part by itself. So log of 7x equals 3/2. Already you guys are loving this problem because it's a fraction, but don't worry, it's not too bad. All right, step 2 says to transform the log term to exponential form. Another way of saying that is if this is log base 10, I can undo it by taking everything like 10 to the power of everything on both sides. So what that looks like for step 2 is I have 10 to the power of log 7x equals 10 to the power of 3/2. So these just undo each other on this side, leaving me with 7x equals 10 to the 3/2 power. If I really want to get x by itself, I divide both sides by 7. And my exact answer is 10 to the 3/2 divided by 7. That, if I stick that in my calculator, is I'm going to come down here and use 10, use my caret symbol. I can put 3 divided by 2 up there. I'm going to hit enter, and then I'm going to divide by 7. So that is approximately 4.52. All right, and that was step 3. So this is step 3. All right. One more example before we finish off Tuesday's lesson is again step 1. We want to isolate just the log part, and in this case we have natural log. So I'm going to add 5 to both sides, giving me -4 natural log of x plus 1 equals 12. Now I want to divide both sides by -4. That isolates the natural log part to natural log of x plus 1 equals -3. All right, so step 2, I need to undo the natural log, and I undo it by taking it, I do the e to the power of thing. So in this case, it's going to be e to the natural log of x plus 1, that's in the exponent, equals e to the -3. These undo each other, leaving me with just x plus 1 on this side, equals e to the -3. And when I subtract 1 from both sides, then I've solved for x. So e to the -3 minus 1 is my exact answer. If I want to do step 3 and put it in my calculator, then I haven't quite figured out the lighting in here, so I apologize. But that still is the little letter above ln, so second ln, put in -3, make sure you use the negative sign, not the subtraction, and then -1, and so my answer is a -0.95. So my answer is approximately -0.95. All right, that concludes today's lesson. Let me know if you have questions on the assignment. It is a book assignment this week.